All right, question 1, we are to write the equation in its equivalent exponential form. So I have 2 equals log base 3 of 9. And so what you do here is you do a counterclockwise motion. Okay, so we're going to do a counterclockwise motion. So we're going to start with the base. It'll be to that exponent, the number after the equal sign is the exponent, equals this number here. So it's going to be 3 squared equals 9. Okay, so there's 1. So a little backwards there because you don't have because it's written after the equal sign, or the equal signs. It's flipped from what we normally see in the notes. Number 2, we have 4 equals log base 6 of m. So we're going to start with the 6 as the base. And so you're going to do 6 to the power of 4 equals m. So 6 to the power of 4 equals m. Okay. So 6 to the power of 4 equals m. All right, another one. 3, we have 5 equals log base b of 32. So we're going to write b to the 5th equals 32. So b to the 5th equals 32. Okay. Hopefully this is not too bad. Whoops, sorry about that. All right, now we're going to go the opposite. It's in exponential form. We got to write it in logarithmic form. So 12 to the 5th is equal to x. So this is going to be your base, and you're going to do the same counterclockwise motion. Okay, so log base 12 of x equals 5. So log, there's your base, and then what's after the equals is your value here, and then your exponent is going to be what comes after the equal sign. So log and to do a base 12 of x equals 5. Not sure why the log was in bold there. Okay, number 5, x squared equals 856. So on this one, we're going to do the base is x. Then you have 856 equals 2. So log base 856. Oh, I'm sorry, log base x of 856. Sorry about that. 856 equals 2. So log base x of 856 equals 2. Okay, get this little subscript button there. All right, number 6, we have 8 to the power of c equals 7. So you just do this counterclockwise motion. Log base 8 of 7 equals c. All right, now express this without using a calculator. So you got a few things you could do here without using the calculator. Log base 2 of 64. So what I could do is rewrite this as an equation. So I could say equal, set it equal to x. So I could do log base 2 of 64 equals x equals some value, and then rewrite it in exponential form. So 2 to the power of x equals 64. And so 2 to what power gives you 64. And you could type that in your calculator to be 2 to the 6th. So 2 to the 6th equals 64. So x equals 6. I need to write this a little differently here. I'm sorry. I'm going to write this. I want to write this like it's written for the answers here. So x equals 6. So log base 2 of 64 is equal to 6. There we go. Flying through these questions. All right, question 8. We got log base 6 of 1/6. Okay, so I could do log base 6 of 1/6 equals x. Okay, so I'm going to do a exponentiate it. So 6 to the power of x equals 1/6. I was getting ahead of myself here. Now we know that 1/6 is equal to 6 to the negative 1 power. If you have a value on bottom, okay, it's like 6 to the first. You can move it to the top by just change the sign of the exponent. So 6 to the x equals 6 to the negative 1. So x equals negative 1. So log base 6 of 1/6 equals negative 1. All right, now this one's kind of similar. We have log base 8 of the square root of 8. Okay, so log base 8 of the square root of 8 equals x. So 8 to the power of x equals the square root of 8. The square root of 8 is equal to 8 to the 1/2 power. Okay, because anytime you have a square root, it's the 1/2 power. So 8 to the x equals 8 to the 1/2. So x would equal 1/2. So log base 8 of the square root of 8 is equal to 1/2. Okay. All right. On 10, we have log base 6 of 6. Okay, so there's a couple different ways you could do this one. This was in your notes. When you have the same base as the exponent, you could do exponentiate it. So 6 to the power of x equals 6. You see 6 has got a power of 1. You see they have the same base, so x equals 1. Okay, now you learned this in the notes too. There's a property. If they have the same base and the same value here, it's just going to equal 1. So log base 6 of 6 is equal to 1. Okay. You could also do change of base when you do log of 6 divided by log of 6. Anytime you're dividing by the same quantity, it's going to equal 1. Express this without using a calculator. So I've got log base 5 of 1. So I'm going to do log base 5 of 1 equals x. So 5 to the x equals 1. So what to the power of what exponent could you put something to give you equal to 1? X would have to be 0 because 5 to the 0 would equal 1. Okay. So log base 5 of 1 equals 0. Okay. Now let's look at the next one. I've got log base 4 of 4 to the 6th. There's a rule in your notes that covers this. Okay. And I'm going to pause this to pull your notes up. All right, so I paused this so you could see here in the notes. Okay, it's just like we did here. Okay, so when you have this, I'm going to write this property down. Log base b of x equals x. Okay, so basically what this means is the logarithm with the base that has the same base and it's raised to the same power here. If these two are the same, it's just equal to the exponent. Okay, so it's equal to the exponent. All right, and so in this case, x will equal 6. So like this right here, yeah, I'm sorry, let me not write there. Log base 4, 6. This right here is equal to 1. And then so you just bring down, so x equals 6. I'm sorry, x equals 6. So I'm going to write this as an equation. So log base 4 of 4, the 6 is just equal to 6. I made that more confusing. Basically, if you have the same base and the same base of the exponent here, it's just gonna, those basically just cancel and you just bring down the exponent. Okay. All right. Kind of the same thing here. You have a base and it's log of the same base with a value. These two things just cancel basically, and you're just left with the value there, that 4. So 2 log base 2 to the 4. I'm going to write this again. This just is just 1, and then you bring down the 4. You bring down the 4, and so 2 log base 2 of 4 is just equal to 4. So if you want to dumb it down, it's just going to be this number right here. Okay. The other parts kind of cancel themselves out. All right, 14, graph f of x equals, I might come back to this later. I'll leave it up. So graph f of x equals 4 the x. And g of x equals log base 4 the x. Okay, so f of x equals 4 the x and log base 4. So I can go to here. I'm going to put a note: math log base on that. Okay, so that'll help you there. So go to y equals. I'm going to do it 4 to the power of x here, and then math log base 4 to the power of x there. Okay, sorry about that. Sorry you couldn't see that. Let's move this. All right, now I'll go to the second graph. Okay, so I've got x, f of x, g of x. So when x is, you got -2, f of x is 0.0625, -1, 0.25, 0, 1, and then when it's 1, it's going to be 4 and 0. When it's 2, it's going to be 16 and 0.5. Okay, so it kind of gives you an idea. 3, and you don't have to do, you could just look at the graphs. I was going to try to plot these, and I'm not going to be able to plot this very well. Okay, so I'll try to graph this here. So -2, 3, 1, 2, 3, 4, 5, 6. Okay, this is just gonna. So you've got the first one goes here, here, 0, 1, 1, 4, 2, 16. So it's going to kind of look like this. There's f of x, and then g of x is going to be there's nothing there. There's an asymptote at x equals 0. Okay, so you got 0, 1, or 0 on the x, 1 on the y. Or not an asymptote, sorry. And then 1, 4. You could look at the graph here too. 1, 4. I'm sorry, 0, 0. There's no 0, 1. 1, 0. I apologize. 1, 0. 2.5, and it actually goes down forever too. I should mention that it goes down forever too, so it's going to look like this. Okay, so it's going to kind of look like that. That's g of x, and so that's going to give you your, and they're reflected across the y equals x line. So that's the other thing. They're reflected across the y equals x line, which cuts it diagonal like that because they're inverses of each other. Okay. Graph 1/5. Let's try this one. 15, I've got f of x equals 1/5 to the x, and g of x equals log base 1/5 to the x. So open parenthesis, no, I won't do that. Let's go back to y equals 1/5 power of x and log base 1/5 to the x. All right, so you can look at the graphs. It's going to be, once again, it's going to be reflected across the y equals x line. This one's going to be decaying because it's going, its base is smaller than 1. And the other one's going to be right there. Okay, I can get you some points if you want to see the points here. So x, I'll move this over a little bit. So x, f of x, g of x. Second graph. So let's do -1, 5, 0, 1, 1.20 to 0.04, -0.431, 3. I've got 0.008 and -0.683. Okay, so I'm going to graph these now. So this one's going to be at, the first one's going to be a decay one. -1, 5, 0, 1. And so it's just going to come in here 1.2, 2.04. So it's going to be like this. So that's f of x. And then g of x. 1, 0. 2 and -0.431. 3 and -0.683, and so this one's going to go up like this forever, and they're reflected across the y equals x line. So this one's g of x. So it should look like that. So one of them's decaying, and then one of them's having to look closely here. Well, no, it's not going to be that one. I apologize. I need to zoom in and see this better. So these two have that, but this one's going, I think it's that one. I can't tell very well. I could not tell that very well. I apologize. And this can be hard to read. So now let's look at these graphs here. So 16, you've got to graph the match with their function. So what I'm going to do is I'm going to sketch the functions here. Okay, we've got 47, which, okay, 47, which looks like, I'm going to pause to sketch the functions because this is boring video. All right, these are going to be transformations, kind of working off. It looks like log base 6 of x. So let's look at the base kind of. I guess you could. I don't know if the parent function's the right word, but it's the one that all these other ones go off of. So I got to math log base 6 of x. Okay, and so there's your log function. Now it's going on, but you can't see that very well. Still can't see that. It goes on forever and ever down. So it's going forever and ever down, and it's going up. Okay. So just trying to get that to where you could see it better. All right. So log base. So it's going down forever, then up. Comes over at 1. So it hits it. It'll hit the x-axis here at 1, and so that looks like it's going to be, this one right here, 52. So 52 is log base 6 of x. So they're all going to transform off of this one. So 52 is log base 6 of x, or f of x equals. Okay. Now let's look at the other ones. How does this one transform? It looks like it's flipped. So it's flipped over the. Well, let's see all the transformations I have. Sorry. So we've got. I could do. Let's look at the next one. Log base 6. Whoops. Y equals. Math log base 6 of negative x. So this one's going to be, when you do a negative to the x, it is a horizontal flip, which is going to make it go, which is going to make it flip over the y-axis. So this one's going to be flipped over the y-axis. So it's going to be this one, this one flipped over the y-axis, okay? So flip it over the y-axis. That's going to make it go like this. And so that looks like 48 to me. So 48. Okay. So 48 would be g of x equals log base 6 of negative x. Okay. Now let's look at the next one, which is log base 6 of x minus 1. That's just going to make this one go down 1. So it's this 52, it's going down 1. So you're going down 1 unit. So which one goes down 1 unit? So it goes from 1, this would be at, it would be at, instead of being at 1, 0, it would be at 1, negative 1. So I'm looking for one that's at 1, negative 1. It looks like it's going to be this. No, that one shifts to the right one. Having a hard time. Let me see. Having a hard time seeing this. Minus 1. I might come back to. I'm going to come back to that one. Okay, this one is going to be 1 right. Oh, I saw that one. 1 right would be this one right here, 51. So 1 right, because it's going 1 right. You see, instead of being at 1, 0, it's a 2 theta shifted at 1 right. Because whenever you subtract the x, it's 1 right. So this would be log g of x equals log base 6 of x minus 1. Okay, let's look at another one here. Negative just flips it. This negative, the whole thing flips it over the x-axis. It's a vertical flip, so it flips it over the x-axis. So it flips this over the x-axis. So then this would be going up, and this would be going slightly under. It's looking like 50 right there. Okay. Now 1 minus log is, it's flipping because it's negative log, and then plus 1 means up 1. So it's flipping, but it's up 1. So flipping and up 1 would be, so you flip it and then you go up 1. Okay, so that would be up 1, so that would be have 1, 1 on it. So which one has that? Looks like it's going to be this one right here, and then this one goes here. Okay. All right, begin graphing f of x equals log base 2 of x and use transformation as graph given function was a vertical asymptote. Use the graph to determine the domain and range. So I've got g of x. So on 17, I've got f of x equals log base 2 of x. G of x equals log base 2 of x plus 2. So all that's going to do when you add 2 to the x, it's going to shift it left 2. So shifts left 2. Okay, so determine the transformation to be shifted 2 units to the left. So graph of f of x equals log base 2 of x. Should be shifted 2 units to the left. Okay. All right, let's go to the next one. Graph the function. So we're going to graph this. And so what you're going to do is click on the graph, and you're going to do, this is the logarithm tool. So click logarithm tool. I think you can just click anywhere, and it's going to tell you it's going to go left 2. So the base is 2, so it's going to go vertical or horizontal shift. Now 2 would be, it'd be negative 2 on this. There you go. So I'm going to help clarify that for you here. So click logarithm tool, and then be horizontal shift, negative 2. And so as you do that, you'll get this sketch here. Okay. Whoops. Apologize there. I forgot about the asymptote. So the asymptote is going to be at x equals, and that's going to be a dashed. So I'm going to make a dashed and negative 2. Apologize about that. So there's a vertical asymptote. Vertical asymptote x equals negative 2. Okay, so the vertical asymptote with g of x, the vertical asymptote is x equals negative 2. Okay. Domain, how far left does it go? What goes to negative 2 but doesn't quite ever hit negative 2? How far right does it go? Infinity. So the domain would be negative 2 to infinity. So negative 2 to infinity. And range, how far down does it go? Negative infinity. How far up does it go? Well, go to infinity. It'll just take it forever to get there. So it'd be negative infinity to infinity. All right, 18, we have another graphing one here. So on this one we have, sorry about that, we have log base 3. I'm going to write this over here. This is a mess now. F of x equals log base 3 of x. And then h of x is equal to 8 plus log base 3 of x. And so what's happening here is it's going to be up 8. It's going to be shift up 8. So on this one, it's going to be shifted 8 units upward. We're going to graph it. And so as we graph it, let's go ahead and click on the graph. Let's go to the logarithm tool. I'm just going to click something there. So you use click logarithm tool. All right, it's going to be a vertical shift of 8. So a vertical shift of 8. Okay. And then we're going to, is that going to stay? Okay, I'm learning how to use this. And then we're going to have a vertical asymptote at x equals 0. Okay, so it's going to go up like this. Okay, that's just going to be kind of a rough sketch there, really rough. All right. Now let's look at the values of the asymptote. Vertical asymptote is x equals 0. It did not move because there's no horizontal movement. Now the domain, how far left does it go? Negative, or I'm sorry, 0, 0, 0, but not including 0. How far right does it go? Infinity. So this would be from 0 to infinity. Let me put a comma there. Range, how far down does it go? Negative infinity. How far up does it go? Infinity. So negative infinity to infinity. All right. All right, so now let's look at these. 19, we have ln of 1. So I can get my notes back out for this. Let me show you in the notes here. This would be better if I showed you in the notes. So ln of 1. Do I have ln in here? Yes. ln of 1. So ln of 1 is just equal to 0. Okay, natural logarithms, because you're basically just saying anything to the power of 0 equals 1. I can prove it to you if you want. Ln of 1, it'd be like ln the base e1 equals x, e the x equals 1, e the x equals 1, so x has to equal 0. So it's just going to be ln of 1 equals 0. Okay, that proves it to you. You could just use the property from the notes. I was trying to show you both ways there. All right, 20, we ln e the 8. And so we basically, kind of like on the last one, on the notes, you had one like this, or ln e to the 8, ln e to the x equals x. It might be better if I just wrote down that property, ln e to the x equals x. So x would equal 8. So equals 8. Okay. (21), a little bit more work here. ln of 1 divided by e to the 18th. So what I would do is I'd rewrite this, and the notes is not going to help me actually as much here. So I'd rewrite this as ln e to the negative 18. Okay, so 1 divided, like if you have 1 divided by that, you could bring this to the top, but you have to make this, change the sign of that. So ln, remember ln e the x equals x. So ln e the negative 18 equals negative 18. (22), we have e to the ln of 118. Okay, I will use the notes here to use that property. E the ln of x, e the ln of x is equal to x. So e the ln of 118 is equal to 118. So that's okay. So I'm using this property here because e and ln they're inverses of each other. Oh, 113. I'm sorry. What am I? I don't know why I wrote down 118. I could just keep that. I'll change it. I don't know where I got 118 from. I apologize. 113. Okay. The percentage of adult heights attained by girls who are X years old can be modeled by f of x. I'm going to write this over here. 23. F of x equals 62 plus 35 log of x minus 4. X represents a girl's age from 5 to 15. F of x represents a percentage of her adult height. Use this function to determine approximately a percent of her height at age 14. So at age 14. So at age 14, that means x equals 14. So I'm going to do f of 14 equals 62 plus 35 log, and then 14 minus 4. And so 62, out of there, 62 plus 35 times log of 14 minus 4 just be 10. Should be 97. So adult height should be around 97%. All right, the sound loudness level of a sound D in decibels is given by the formula D equals 10 log 10 to the 12th I, where I is the intensity of the sound. It's like 1/2, it's 10 to the 12th. Okay. Decibels can range 0, which is barely audible, to 160, or ruptured eardrum. The certain sound of an animal can be heard 500 miles away. Intensity is 7.3 times 10 to the 5th watts per meter. Determine the decibel level of this sound. So intensity, I've got the intensity equal to 7.3 times 10 to the 5th. Determine the decibel level at that. So what I'm going to do is I'm going to do D equals 10 times log of 10 to the 12th times 7.3 times 10 to the 5th. Okay. So 10 times log of 10 to the 12th times 7.3 times 10 to the 5th And so it'd be 178. Ooh, that's an issue because that's a ruptured. I don't know if it goes. I don't know if it's supposed to. Oh, so it can't. So I guess it is. So it'd be 178.63. Oh, nearest whole number. So 178 or 179 decibels. So can that rupture an eardrum? Yes. All right. So it could rupture it because it's greater than the 160. Use transformations of the graphs of f of x equals ln of x to graph the following function graph. And so what I'm going to do here is f of x equals ln of x, g of x equals ln of x plus 5. So the adding 5 to the x, it's going to shift it left 5. So shifts graph left 5 units. Okay, so the transformation's needed to, so it's going to be horizontally shifted left 5 units. All right, I'd like to apologize. I realized I wasn't recording there. So on this one, some things I talked about here was that no one listened to, was that this can't be, it has to be greater than 0, but with the squared, it's never going to be negative. It's never going to be negative. So this is not going to be negative, so we don't have to worry about that. The problem is it can't equal 0. And so it equals 0 when x minus 17 cannot equal 0. So basically at 17, it can't be 0. Okay, and so it's not going to include 17 in the domain. And so I basically, it's everything excluding 17. So from negative infinity to 17, unit 17 to infinity. Okay, because it can't be 17. All right, so f of the bar graph shows the percentage of adults who have put off medical treatment 7 selected years come to expense. The function f of x. So f of x equals, I'm going to erase this a little bit better here. This was not erased well enough. 5.7 ln of x plus 19 models the function there, and x is years after 2000. Answer parts A and B. Use a function to do, so x years since 2000. So 2019 would be x would equal 19. So so I'm just going to plug in 19 into there. So f of 19 is equal to 5.7 ln of x plus 19, or ln of 19 plus 19. So 5.7 ln of 19 plus 19. And it's going to be how many decimal places around the nearest percent? So 35.78. It's around 36%. So now that's 36% for 19, and it's the same as the bar graph. So 36, it's 36 in the bar graph as well. So it's going to be the same as the bar graph. B, use the function to project adults who will put off in 2023. So in 2023, x equals 23. And so it's going to be f of 23 is equal to, oh man, that's so close, 36.87. Let me write the expression here with 23 plugged in. So 5.7 times ln of 23 plus 19. It's around 37%. So the percentage of adults who put up in 2023 is 37%.